Howdy folks. On November 15th, 2022, HEASoft version 6.31 was released. There are some pretty substantial changes to HEASoft with version 6.31, especially for Mac users out there and analysts of IXPE and NICER data. Me primarily being someone who works a lot with NICER, we're going to go into the weeds a lot more and take a look at some of those big changes with NICER, so stay tuned for that. We'll also go through some more and I'll just highlight a few of the changes with HEASoft 6.31 that I just think are important and to kind of bring to all of your attention. That said, all the sources for this will be linked in the description down below, as well as there will be a table of contents. So if I start discussing something you don't necessarily care about, you can skip to something you probably care about. But before we get started though, I want to welcome all of you who are seeing me for the first time, and welcome those of you back who are seeing me, well, not for the first time. My name is Nick, and I am an independent researcher in higher energy astronomy, astrophysics, physics, data science, applied mathematics, and those sorts of things. That said, here's your one-time disclaimer that I am an independent researcher. I am not affiliated with any of the missions or organizations, agencies, whatever you want to call them, that I mentioned in this video. I am an independent researcher. So that means I'm not affiliated with NASA, the Goddard Space Flight Center, the HEASarc, the NICER mission, nor am I affiliated with any academic institution. I am independent. I do this work on my own time and my own dime. But let's get started. All right, so first off, we're going to go through these release notes. I'm just going to highlight a few important things with these release notes. First of all, HEASoft 6.31, released November 15th, 2022. So for those of you who are just installing HEASoft, let's say for the first time, you can go ahead and install HEASoft following the same exact instructions for a source code installation, at least, using my tutorial on HEASoft version 6.28. It's the same exact process, at least if you're going to be on an Ubuntu or Debian-based system. Now, as I mentioned, a lot of these changes, or the most major changes, come to the IXPE and NICER missions. Both IXPE and NICER are newer, relatively newer missions compared to, let's say, like a mission like RXTE that is, a past mission. But I still do happen to go through a lot of RXTE data. Upgrading to a new version of HEASoft, if I'm just analyzing RXTE data, isn't the most important. But especially if you're working with newer missions, or at least active missions, you're going to want to be upgrading to these latest versions. And especially if you're a NICER user, when we get to that stuff, you're really going to want to be upgrading here. However, you're also going to want to upgrade if you're a Mac user. There is added support for the new Silicon ARM64, so if you're using a newer Mac system, you're going to want to be upgrading to HEASoft version 6.31, as you can see with these notes. I'll allow you, again, it's linked in the description, to read through them. I'm not going to go through this in too much detail. Now, I'm not going to talk too much about IXPE just because I haven't worked enough with it where I'm comfortable giving you advice on how to work with IXPE data at all. But there's one really important note here that I want to point out, and that is that with IXPE, the Python source code has been moved out of HEASoftpy. So I don't want anyone to think that if you are installing or using HEASoftpy, you're going to be able to work with the IXPE tools. You're going, they're still co-located with HEASoftpy, but don't think that if you just install HEASoftpy, you're going to be working with those IXPE tools. Now, the last thing that I want to point out here is a big change with Cal tools, and this is before we get into the NICER stuff, because NICER is going to have their own thing. But we have QUZ-CIF2, which is a new task that is intended to go ahead and replace the original QUZ-CIF. So for those of you that are familiar with QUZ-CIF, I would suggest, at least for me at least anyways, I've begun working with QUZ-CIF2 rather than QUZ-CIF, just to get used to QUZ-CIF2, because it, again, is intended to replace QUZ-CIF. Alright, so now we're going to dive into the big changes to come with NICER. And again, I pretty much work with NICER data every single day. Being somebody who studies neutron stars, the Neutron Star Interior Composition Explorer should obviously provide pretty adequate data for the work that I end up doing in studying neutron stars. So let's get into a lot of these big changes. Just from a general, very broad point of view, there are three really big things that I want to highlight with the changes to come to NICERDAS, or the NICER software, in HEASoft version 6.31. First, you have the integration of background models. You have the Scorpion model, 3C50, and Skyweather models. That kind of brings us to the next big addition, which is NICER L3. There's NICER L3 Spec and NICER L3 LC, which are level 3 standard product pipelines that are going to generate all the standard products that you need to go ahead and do spectrum or light curve analysis. But then because of all of that and the integration of those background models, now the use of geomagnetic quantities is a requirement. Not only is it a requirement, but you need to have those geomagnetic quantities installed locally. And so that is where we're actually going to start. So I'll refer you over to the NICER data analysis threads. There's a lot of really valuable information here. I'll link it in the description down below along with everything else. But what's more important here is this thread on retrieving and using geomagnetic quantities. The geomagnetic quantities are actually pretty easy and straightforward to get. So to work with the geomagnetic quantities, we're going to need to set up a GeoMag path. So what you can see I'm doing here is I'm making a directory called GeoMag within my HEASoft 6.31 directory, and that's where all of the geomagnetic quantities or the geomagnetic data is going to be stored. In reality, you can make this anything you want, but I think a dedicated GeoMag path in the HEASoft directory is appropriate. Then we are just exporting this GeoMag path. It's GeoMag path in all caps, and that's the path to that geomagnetic directory I just created. Then we're just going to add that to our bash RC, and you're going to want to do all of this after installing HEASoft 6.31, because now we need to actually access and get these geomagnetic quantities, and we're going to do that by using this NIGeoDown command. NIGeoDown is just a tool in NICERDAS, and it is going to retrieve all of the geomagnetic quantities to our GeoMag path. And if we open up that geomagnetic directory, you can see all these files right here, which is our geomagnetic data that is going to be required for us to work with NICER data or do NICER data reduction with HEASoft version 6.31. Now previously I had the GeoMag path set to this link right here, where it would just be retrieved remotely. You won't be able to do that anymore with HEASoft version 6.31. I spent a few hours trying to actually get it to work and I couldn't do it. Maybe there is a way to do it, but just from my experience, I have not been able to get those remote GeoMag quantities to be, to work with NICER L2 and everything else that's going on right here. And to kind of show this, I'm going to show you what's going on here with NICER L2 and some of the new additions right in there. So if we go ahead and take a look here I have a terminal window. I'm using AutoNICER. For those of you that don't know, AutoNICER is just a simple pipelining tool that I have that allows you to quickly and easily retrieve and reduce NICER data. So it is working with HEASoft version 6.31. Stay tuned in the next few days here for a video on a new release with some new functionality. But I've chosen this particular observation right here, 301, 301, 102. From the crab pulsar, and you can see here with NICER L2, one of the things that you end up starting to see is these GeoMag columns. Before, this is something that could just be ignored, but it is now a requirement. You need to be using, you need to have those GeoMag quantities, and it's going to be looking for the GeoMag path. If it doesn't find the GeoMag path, you're going to run into some issues down here with the NICER pre-filter 2. You can see right here, again, it's looking for that GeoMag stuff, and it has picked up that GeoMag directory that I've set up. So you're pretty much not going to be able to do really next to anything without those geomagnetic quantities. So it's really important that you go ahead and do that. Again, I just went ahead into the HEASoft directory, source directory, made a new directory called GeoMag, and then just put the path to that as the GeoMag path. And you should be kind of all set to go, and you can run NIGeoDown to retrieve those geomagnetic quantities. Now, the other thing I want to mention quickly here with NIGeoDown is that there is this chatter parameter that's going to kind of help in diagnosing errors. There isn't too much else kind of listed with that, so I haven't really used the chatter parameter yet, but you can go ahead and give it a try if you're encountering some issues. Now, one last thing I want to highlight with regard to the geomagnetic quantities or the geomagnetic data is that it needs to be updated routinely. There is a little bit of help here with regard to setting up a cron job for this to go through and download every day. But for me, I'm usually processing really, really large amounts of data kind of at any point in time. So for me, what I end up doing is I just end up going and I'll run NIGEO down, and then I'll start reducing that data and churning through things, or even better yet, that is something I'm looking to just add into AutoNICER. So if you are a user of AutoNICER, it's just going to go through and pull those geomagnetic quantities at a certain interval. But a cron job is just as easily set up. It's just up to you with how you want to set that up. And now with that, those geomagnetic quantities are really important for background models. Those background models are really, really important. You can see right here, this is the Scorpion background model overview page. Again, I'll link that in the description, but I want to really highlight this table right here, which I found to be particularly helpful. There is the Scorpion model, the 3C50 model, as well as the space weather model, and all of them are kind of useful in different scenarios. So I'll highly encourage you to check out this table whenever you're going to be working with stuff to figure out what's going on. I haven't really worked too much with Scorpion, and that's because I'm having a few of my own kind of personal issues with it. And I am working with it to kind of figure out what's going on with it. But I do really like the 3C50 model for the spectrum related stuff. And then space weather is also great as well. Now, these models, though, are going to be primarily useful with regard to the new standard product pipelines, NICER L3 LC and NICER L3 SPECT, for generating your light curve standard products and your spectrum standard products. So let's do a little bit of a demonstration for those, just to kind of give you a general idea of what's going on there. Okay, so as you saw before, I went ahead and reduced everything. You can go ahead in here, and we have this 301, 301, 102 data set from the Crab Pulsar. I've specifically chosen this one just because I know it's only a few hundred seconds and it's the Crab, so we're going to get a good enough spectrum out of this. Now we've just backed out and we're sitting right in the main directory that contains our full OBS-ID data set, if you want to call it that. And you can see here we have this NICER L3 SPECT tool right here. We're going to set our observation ID second, and we can set a BKG model type. That's our background model type. Again, I'll refer you back to that table to kind of determine what you want. And there's also this clobber parameter. We can go ahead and just hit enter, and NICER L3 SPECT is going to go ahead and run, and it's going to create the background in all the different files you might need. So I'll give that a few minutes just to run here. But the one thing that I want to just mention is that now with this new NICER L3 SPECT tool, you don't really need to worry too much about generating your ARFs and RMFs manually. Of course, you can still do that. You can still work with these tools manually, but the pipeline is there to really simplify so many things. Now this will take just a few minutes to go ahead and run. And while we have that going here, there is an entire thread dedicated to the complete spectral product pipeline. Again, linked in the description down below. It'll be right in here, and it'll kind of give you all the commands you want to do. One of the things is that you don't need to set a background model. It will just default to using Scorpion if you want to use Scorpion. The other thing that we can do is you can see here in this particular bit of documentation, you can specify a GTI file for whatever you want to do with specific good time intervals. And so you can see, again, this isn't really being the fastest. When we get to the NICER L3 LC tool, you'll see that that tool is much faster than this, but there's a lot more going on here. So you can see we have the background file, we have the night file, day file, ARFs, target ARF, sky ARF, the RMF, and everything's done right here. But what you have here is this XCM file that's being produced, where all of this is going to be able to be loaded in pretty much one command into XSpec. So let's go ahead and demo that. We can come in and type it, go and load up XSpec. And you can see that everything's kind of coming right in here. You have this ignore bad, and everything's kind of just being loaded right away, right in here. So we can go CPD and back out to XW. And yeah, here's your spectrum. You can see it right in here, and that's using everything that we have going on right in there. If we, let's say, just for the sake of argument, we can just do a simple PHABS by power law And again, this is just for the crowd. We'll just kind of let it fit on its own, and then we'll plot. Again, it's actually not too bad of a really crude fit going on right now, but that's kind of what what you'd expect. But you can go ahead in here and see just how quick and easy it is for me to just generate stuff and start playing with things right away. Whereas before, we have to start messing with and dealing with those ARF and RMF files a lot like crazy. So this is really, really nice, and it's something that I wanted to incorporate into, or I wanted to actually come up with AutoNicer, but back with the NICER data analysis webinar or workshop or whatever you want to call it back at the end of August, beginning of September 2022, that actually mentioned that they were going to go ahead and come up with NICER L3. So for those of you who are AutoNicer users, this is something that's going to be integrated right in there to generate those standard products for you, especially these Spectrum standard products. But let's now take a look at NICER L3 LC. Okay, so as you can see right here, we have the complete light curve product pipeline with NICER L3 LC. Again, this is going to generate your standard light curve products, and it's just a simple pipeline for that. You can see a really easy example of usage. I'll show you kind of how I am going to be using this a little bit more, just because I have my own light curve software that I've developed to kind of do my own light curve stuff, so we're not going to focus too much on that. But again, this documentation will also be linked in the description down below. This is a really great reference tool to use right here. So let me just go ahead and show you this demo. Here, again, we're sitting in that same directory, NICER L3 LC. We're calling the tool, our observation ID. We're setting our energy range 200 to 1200. I kind of like that range a little bit better than what they had in the demonstration. And you can see I'm setting my time bin here to a kilosecond. Okay, so some of you might be really weirded out by why I've set that time bin to be a kilosecond. And that observation, again, I've chosen this observation particularly because I know it's only a few hundred seconds. But when I'm not really using my own software for light curve stuff, I do like to use the software in HEASoft to generate those light curves. And one of the things I really like to do with it is just to kind of get a general count rate for NICER, and a really easy way of doing that is just to build a light curve. I can just go ahead and I can say, okay, the observation is, let's say, 500 seconds. So I just set a time bin that's larger than 500 seconds, and I get a really easy count rate. And then I have a light curve file or a FITS file where I can just kind of go right in there and pull that out with the error and get a count rate. And so that's what we're going to be doing here. We can run this, and it's going to run. So you can see I actually kind of messed it up. It doesn't really like that energy range, and it's probably because I've put the decimal point, probably looking for integer values. And so you can see here it's creating that light curve for me, and it's done. It's done just like that. And we can kind of just work our way right into here, into our XDI cleaned event directory. And here you can see our light curve where it's just one data point, and we get a count rate, which is exactly what I wanted. All right, and so those are really the big main changes to come to HEASoft version 6.31 and the NICER software. We have the requirement of those geomagnetic quantities, so really make sure that you have that installed. And again, you're updating that and installing those locally. Again, you're not going to be able to do it remotely. At least in my experience so far, I haven't been able to do that. You have your standard product pipeline, so use those instead of doing things manually, as you can really mess things up by doing them manually. These pipelines are really quick, they're really simple, they're really easy, and I'm a big fan of them. That's why I was interested in kind of doing something like that before, and I'm really happy to see that the folks over with the NICER team ended up creating those, because they're just, they make life so much easier. And then again, the really, really big thing that I think a lot of people are really going to be happy with are the new addition of those models. Again, I'm going to throw the table right up on the screen here, where you have 3C50, Scorpion, and Skyweather. Use those accordingly, and use that table to kind of help you decide, what model you're going to want to be using for, whatever your use case might be. But that's going to do it. I just wanted to touch on some of the new functionality with the NICER software, highlight some of the important changes and other things to go on with HEASoft version 6.31. And I know that there are some of you that kind of don't stay up to date with the RSS feed or stay up to date with what's kind of going on at the HEASoft. So this might be your first time seeing or hearing that HEASoft version 6.31 is out, although it's been out for, I don't know, a little more than 2 weeks maybe. And so you should definitely upgrade to HEASoft version 6.31. Again, I know I said I would only kind of give the disclaimer once, but I'm an independent researcher. I just utilize HEASoft and NICER data, as well as many other missions data sets, to facilitate my own independent research work into neutron stars. Okay, I started doing it as a student in university, and I continue doing it now just because I enjoy it. I really do enjoy it. I'm fascinated by these things. I love doing it, and I'm going to keep doing it for a while. So if applied mathematics, data science, physics, any of this stuff kind of interests you, I mean, you know where to find me now. If you're seeing me for the first time, for those of you guys returning, thanks for returning. And if you have any questions, comments, or concerns, don't hesitate to let me know in the comment section down below. I'll also leave a link in the description to if I could find the NICER help desk, so you can go ahead and submit questions you have to that help desk. But otherwise, if you want my help, please try to give a descriptive description of what's going on, because I'm only so useful in a comment section. Okay, so I want to thank you all very much for watching. Thank you for watching. Hopefully this was helpful or informative to you, and I'll hope to see you again next time.